friends, now we'll start the next exercise 1.3 subsets, power set and the universal set. Subsets. Consider the sets X is equals to set of all students in your school and Y is equals to set of all students in your class. We note that every element of Y is also an element of X. We say that Y is the subset of X. The fact that Y is a subset of X is expressed in symbols as Y is a subset of X, and this is the symbol. The symbol subset stands for is subset of or is contained in. Definition. A set A is said to be subset of B if every element of A is also the element of B. In other words, A is a subset of B if small a belongs to A, then the small a also belongs to B. It is often convenient to use the symbol implies, which means implies. Using this symbol, we can write the definition of subset as follows. What is that definition? That is, A is a subset of B if A belongs to capital A, implies that A belongs to B. We read the above statement as A is a subset of B if A is an element of capital A, implies that a small a is also an element of capital B. If A is not subset of B, we write A is not subset of B, and this is the symbol. We may note that for A to be a subset of B, all that is needed is that every element of A is in B. It is possible that every element of B may or may not be in A. If it so happens that every element of B is also in A, then we shall say, that is, then we shall also have B is a subset of A. In this case, A and B are the same sets, so that we have A is a subset of B and B is also a subset of B. Then it implies that A is equals to B, where the this symbol is the symbol for the two-way implications and is usually read as if and only if, and it is briefly written, and that is IFF. It follows from the above definition that every set A is a subset of itself. that is A is a subset of A, since the empty set phi has no element, we agree to say that phi is subset of every set. We now consider some examples. First, the set Q of the rational numbers is a subset of the set capital R of real numbers, and we write Q is a subset of R. Second, if A is the set of all divisors of 56 and B is a set of all prime divisors of 56, then B is a subset of A, and we write B is a subset of A because B is the set of, that is the prime divisors of 56, and A is all the divisors of 56. Therefore, the A is the biggest set and B is the smallest. Therefore, the B is a subset of A. Let capital A is equals to 1, 3, 5 and B is equals to X is such that X is an odd natural number less than 6. Then A is a subset of B and B is also subset of A. What is that here? First A, 1, 3, 5. These are the odd numbers. And what about the next? B, X is such that X is an odd natural number less than 6. Then what are the odd natural numbers? That is a 1, 3, 5. It means that A is a subset of B, B is a subset of A, and hence A is equals to B. Next, let A is equals to A, E, I, O, U and B is equals to, in curly bracket, A, B, C, D. Then A is a not subset of B. That is, A is not subset of B, and also B is a not subset of A. If a set A has only one element, we call it as a singleton set. Thus, the singleton element, that is the set A, is a singleton set because it has only single element, one element. Example, consider the sets phi A is equals to 1, 3, B is equals to 1, 5, 9, C is equals to 1, 3, 5, 7, 9. Insert the symbol subset or not subset between each of the following pairs of sets. First, phi and B. Okay, it's clear that every set has an empty set. Therefore, phi is a subset of B. Every set contains the empty set. Therefore, phi is subset of B. Phi is a subset of every set. A and B. Now see this A. A means what? 1, 3. And B means what? 1, 5, 9. Therefore, A is not subset of B. A is not subset of B because 3 belongs to A and 3 does not belongs to B. A and C. See this here A. It has element 1, 3 and C has 1, 3, 5, 7, 9. Both element 1 and 3 belongs to C. A is a subset of B. 1, 3 belongs to A. Also belongs to C. B and C. 1, 5, 9, 1, 5, 9. Both the element. The solution, B is a subset of C, that is, as each element of B is also an element of C. Example. Next example. Let A is equals to in curly bracket A, E, I, O, U and B is equals to B, C, D, A. Is A is a subset of B? No. Why? B is a subset of A? No. Why? Can write its answer. Next example. You can solve the above example. Next example. Let A, B and C be three sets. A is a subset of B. B is a subset of C. Is it true that A is a subset of C? If not, give an example. Now see the solution. No. Let A is equals to in curly bracket 1 and B has the element, that is a singleton element 1 and 2, and C has the 1, 2 and 3. Here A has a singleton element, that is a 1 belongs to B, as A has a singleton element 1 and B is a subset of C. It's a clear that all the elements of B is in C. But A is not subset of C, as 1 belongs to A and 1 does not belongs to C. And here note that an element of a set cannot be a subset of itself. Subsets of set of real numbers. There are many important subsets of set of real number capital R. We give below the names of some of these subsets. The set of natural numbers n is equals to 1, 2, 3, 4, 5 up to the infinity. This is a subset of set of real number. Next, the set of integers z is equals to, that is a dash dash minus 3 minus 2 minus 1 0 1 2 3 up to the infinity. And this set of integers is also the set of real number. The set of rational numbers capital Q is equals to x is such that x is equals to p upon q, where p and q belongs to z and q is not equals to 0. That is also the subset of real number, which is, we can read this as q is a set of all numbers x such that x equals to the quotient p upon q, where p and q are the integers and q is not 0. Members of q include minus 5 and which can be expressed as minus 5 upon 1, 5 upon 7, 3 and 1 upon 2, which can be expressed as 7 upon 2 and minus 11 upon 3. The set of irrational numbers denoted by capital T is composed of all other real numbers. Thus, that is that T is equals to x is such that x belongs to set of real number and x does not belongs to set of rational. That is, all the real numbers that are not rational. Members of T includes what type of the numbers, that is the root 2, root 5 and pi, this type of the numbers. Some of the obvious relation among these subsets are, what is the relation? Now see this relation. That is here, that is set of natural number is a subset of Z and Z is subset of X of Q. Q is a set of real number and next is a T is a subset of R and N is a not subset of T. That is a set of irrational number. Intervals as a subset of capital R. Let AB belongs to set of real number and A is less than B. Then the set of real numbers, that is a Y such that Y lies between A and B, is called an open interval and is denoted by open interval, that is a AB. All the points between A and B belongs to the open interval AB, but it's very important, A and B themselves do not belong to this interval. The interval which contains the endpoints also is called the closed interval and is denoted by closed interval AB. Thus, closed interval AB is equals to X is such that X lies between A and B and X is equals to A, X is equals to B also. Okay. We can also have the intervals closed at one end and open at the other. That is, here the first left side, that is the left end, is closed and the right end is open. It means that A is contained in that set, in that interval, but B is not. That is, this can be written as, that is a closed interval A and B open is equals to, in curly bracket, X is such that X lies between A and B, X is equals to A, is an open interval from A to B, including A but excluding B. Next is A is open and B is closed, and here we can write that is equals to, in curly bracket, X is such that X lies between A and B and X is equals to B is an open interval from A to B, including B but excluding A. These notations provide an alternative way of designating the subset of set of real numbers. For example, if A is equals to the open interval minus 3, 5 and B is equals to closed interval minus 7, 9. And here A is a subset of B. It's clear that the set 0, closed interval 0 and open interval infinity defines the set of non-negative real numbers. Non-negative real numbers, that is, it is from 0 to infinity, while the set minus infinity to 0 defines the set of all negative real numbers, and the set minus infinity to plus infinity describe the set of all real numbers in the relation to a line extending from minus infinity to plus infinity. On real number line, various types of intervals described above as a subset of real number capital R are shown in the figure. Now see this one by one. Now in first figure, we will say this here is an open interval A and B. A and B both are not included, but in between A and B it is included. Next is a closed interval AB. Both A and B and between all the elements A and B is included in this set. Next is semi-closed. That is, here is a closed and B is open. A is included and B is not included. Therefore, it is marked in this circle. Next is open. A is open and the B is closed. And here A is a white circle and B is a dark circle, which is A is not included and B is included. Here we note that an interval contains infinitely many points. An interval contains infinitely many points. For example, the set X is such that X belongs to set of real number and X lies between -5 and 7 and equal to 7 also. That is, the interval contains the infinitely many points. Written in set builder form can be written in the form of the interval as open interval -5 and the close is 7, and the interval closed interval -3 and open 5 can be written in the set builder form as, we can write it, X is such that X lies between -3 and 5 and equal to 3 also. The number B minus A is called the length of any of the intervals. Okay, what is that? Here is open interval AB, closed interval AB, semi-closed and open AB, open and the closed AB. If you want to find out its length, then it's simple that B minus A is called the length of the interval. Power set. Now we learn the next concept. Consider the set. It has the two elements 1 and 2. Let us write down all the subsets of the set 1, 2. We know that phi is a subset of every set. So phi is a subset of 1, 2 also. We see that we can write 1, singleton element 1 and 2 are also the subset of 1 and 2. This subset of 1, 2. Also, we know that every set is a subset of itself, and so 1, 2 is a subset of 1, 2. And now see this, how many subsets are there? Okay. Thus, the set 1, 2 has in all 4 subsets, namely first 5, 1, 2 and 1, 2. Thus, set of all these subsets is called the power set of 1, 2. Set of all these subsets, that is the set of all these subsets is called the power set of 1, 2. That is, here we consider the 1, 2, then the power set of 1, 2, that is a 5, 1, 2 and 1, 2. Now the next. Definition. The collection of all subsets of set A is called the power set of A. Collection of all subsets of A is called the power set of A and is denoted by P of A. In P of A, every element is a set. Thus, as in above, if A is equals to in curly bracket 1, 2, then P of A is equals to 5, 1, 2, 1, 2. Okay. Also, note that n of P of A is equals to how many elements in the power set? That is equals to 4. 1, 2, 3, 4. And this can be written as that is 2 raised to 2. How many elements was there in set A? That is 1, 2. This is a 2. That is a 2 raised to 2. In general, if A is a set with n of A is equals to m, then it can be shown that n of P of A is equals to 2 raised to m. N of P of A is equals to 2 raised to m. Universal set. Usually in a particular context, we have to deal with the elements and subset of a basic set which is relevant to that particular context. For example, while studying the system of numbers, we are interested in the set of natural numbers and its subsets, such as the set of all prime numbers, set of all even numbers when we consider the set of natural numbers, and so forth. This basic set is called the universal set. Means in that case, the set of natural number is a universal set. The universal set is usually denoted by capital U and its subsets by the letters A, B, C, etc. For example, for the set of all integers, the universal set can be the set of rational numbers. This will be the set of rational number, or for that matter, the set of capital R, that is the set of real numbers. For another example, in human population studies, the universal set consists of all the peoples in the world. Now see this here again, I will explain here. For example, the set of all integers, and for the set of integers, we have the universal set. What are the universal sets? The set of rational number will be universal set, and the set of real number is also universal set. Next example, for another examples, that is in human population studies. Okay. Then what is the universal set? The universal set consists of all the peoples in the world. I will start the exercise 1.3. Now the first example. Make correct a statement by filling in the symbol belong subset of and not subset of in the following blank spaces. The first set is a 2 3 4, and the next is a 1 2 3 4 5. Now all the elements, that is a 2 3 4 is contained in this set, therefore it's a subset of, that is a 2 3 4 is a subset of 1 2 3 4 5. Next is ABC, and here is a BCD. It's clear that ABC is a not subset of BCD. Next is X is such that X is a student of class 11 of your school. And next another set is a X is such that X is a student of your school. Okay, this is a first set is a of your class, and next is a of your school. Therefore, it's clear that is X is such that X is a student of class 9 of your school is a subset of X is a student of your school. Next, X is such that X is a circle in a plane, and next is a X is such that X is a circle in the same plane with the radius 1 unit. Solution: X is such that X is a circle in the plane, and here it's a not subset, that is a X is a circle in the same plane with the radius 1 unit. Here it is restricted that the radius must be the 1, and he said that here the X is a circle in the plane. Okay, and that's why it is now not subset. Next example is a X is such that X is a triangle in a plane. And what about the another set? X is a rectangle in the plane. Now here X is such that X is a triangle in a plane is a not subset of X is such that X is a rectangle in the plane. Next, X is such that X is an equilateral triangle in the plane. Next is X is such that X is a triangle in the same plane. X is such that X is equilateral triangle in a plane is a subset of X is triangle in the same plane. That is, the next set is such that X is a triangle in the same plane, means all types of the triangles here. Suppose here X is such that X is a isosceles triangle, then it is also the subset. Okay. Now the next is X is such that X is an even natural number, and here is a X is such that X is an integer. Okay, so no problem, it's a subset. X is such that X is a even natural number is a subset of X is such that X is an integer. Now, next example. See this here. Examine whether the following statements are true or false. The first set is AB is a not subset of BCA. False. This set is subset of BCA. Each element of AB is also an element of BCA. Next, AE is a subset of X is such that X is vowels in English alphabet. Now the solution, it's a true. That is, A are the vowels of the English alphabet. Next, third one is a 1, 2, 3 and 1, 3, 5. It's a false. 2 is not, 2 does not belongs to 1, 2, 3. Sorry, 2 belongs to 1, 2, 3. However, 2 does not belongs to 1, 3, 5, and therefore the given statement is a false. Okay. A is a subset of A, B, C. Yes, it is a true. Each element of A is also element of A, B, C. Next is A is not subset of A, B, C. It's again false. That is the elements of A, B, C are the A, B, C, and therefore the A is a subset of A, B, C. Next example. X is such that X is an even natural number less than 6 is a subset of X is such that X is natural number which divides 36. Now we have see this. It's a true. X is an even natural number less than 6 is equals to 4. These are the even natural numbers which are less than 6. And X is such that X is a natural number and divides 36. Then what are the elements? That is 1, 2, 3, 4, 6, 9, 12, 18, 36. These are the elements which divide 36. And therefore 2, 4 belongs to this 1, 2, 3, 4, this big set, and therefore it is a subset. Next is, let A is equals to 1, 2, next element that is a 3, 4 and 5. Which of the following statements are incorrect and why? Okay. The first is 3, 4 is a subset of A. The statement 3, 4 is a subset of A is incorrect. Element cannot be subset. Okay. 3, 4 is an element. 3 belongs to 3, 4. However, 3 does not belongs to A. Next is a 3, 4 belongs to A. Yes, it's a clear. It's a true. The statement 3, 4 belongs to A is a correct because 3, 4 is an element of A. Third, the set 3, 4 is a subset of A. Yes. The statement that is a set 3, 4 is a subset of A is a correct because 3, 4 belongs to this element that set and 3, 4 that is belongs to that set A. That element belongs to that set A. One belongs to A. This statement 1 belongs to A is a correct one because 1 is an element of A. 1 is a subset of A. It's not. It's incorrect because an element of a set can never be a subset of itself. Next is 1, 2, 5 is a subset of A. The statement 1, 2, 5 is a subset of A is correct because each element 1 to 5 is also element of A. Again 1 to 5 belongs to A. The statement 1 to 5 belongs to A is incorrect because 1 to 5 is not an element. There must be the curly bracket in this set. Okay. Next is 1 to 3 is a subset of A. Again, the 1 to 3 is a subset of A is incorrect because 3 does not belongs to 3 belongs to 1 to 3. However, 3 does not belongs to that set capital A. Now the next is 5 belongs to A. The statement is again 5 belongs to A. It's incorrect because phi is not element of A. Phi is a subset of A. Phi is subset of A? Yes. The statement phi subset of A is correct because phi is a subset of every set. Next, phi, that is this set phi is a subset of A. The statement phi subset of A is incorrect because phi belongs to phi. That's it. However, phi does not belongs to A. Next example. Write down all the subsets of the following sets. First, set A, that set contains the element singleton element A. The subset of A are phi and these singleton element A. AB. The subset of AB are phi, A, B and AB. Next is 1, 2, 3. Again, that's very simple. Again, the subset of 1, 2, 3 are phi, 1, 2, 3, 1, 2, 2, 3 and 1, 3 and 1, 2, 3. So, fourth is phi. The only subset of phi is phi. Question number 5. How many elements? Next question. How many elements has P of A if A is equals to phi? We know that A is a set with m element, that is n of A is equals to m. Then n of P of A is equals to 2 raised to m, and this is the formula. If A is equals to phi, then n of A is equals to 0. It's empty. And therefore, power set of A, that is n of P of A is equals to 2 raised to 0 and 2 raised to 0 is 1. And hence, the P of A has one element. Next question. Write the following as intervals. X is such that X belongs to set of real number and X lies between -4 and 6 and equals to 6 also. Now the solution. X is such that X belongs to set of real number, and here open 4 is open and the 6 is closed. 4 is not contained in this interval, but 6 is contained. there is a less than or equal to sign. Next is x is such that x belongs to set of real number and x lies between minus 12 and minus 10. It's clear that it's an open interval minus 12 minus 10. Next is x is such that x belongs to set of real number and x lies between 0 and 7. And here the solution, x is such that x belongs to set of real number. 0 is closed and 7 is open. X is such that x belongs to set of real number, and here is x lies between 3 and 4, equal to 3 and equal to 4 also. Therefore, it's a closed interval. Okay, closed interval 3, 4. Question number 7. Write the following intervals as intervals in set builder form. First is minus 3, 0. It's open interval. The solution minus 3, 0 is equals to x is such that x belongs to set of real number and x lies between minus 3 and 0. Second, 6 and 12. Solution, closed interval 6 and 12. X is such that x belongs to set of real number and x lies between 6 and 12, equal to 6 and equal to 12 also. 6 and 12. That is 6 is open and 12 is closed. Therefore, x is such that x belongs to set of real number. X lies between 6 and 12 and equal to 12 also. Minus 23 and 5. It's a semi-closed and open. That is x is such that x belongs to set of real number and x lies between minus 23 and 5 and equal to 23 also. Question number 8. What universal sets would you propose for each of the following? First, the set of right angles. Here are all the triangles. For the set of right angles, the universal set can be the set of triangles or the set of polygons. Second, the set of isosceles triangles. Again here, for the set of isosceles triangle, the universal set can be the set of triangles or the set of polygons or the set of two-dimensional figures. Next is question number 9. Given set capital A is equals to 1, 3, 5 and B is a 2, 4, 6 and C is 0, 2, 4, 6, 8. Which of the following may be considered as a universal set for all the three sets A, B, C, A, B and C? The first is 0, 1, 2, 3, 4, 5, 6. It can be seen that A is a subset of this 0, 1, 2, 3, 4, 5, 6. B is a subset of again 0, 1, 2, 3, 4, 5, 6. However, C is not subset of 0, 1, 2, 3, 4, 5, 6. Therefore, the set 0, 1, 2, 3, 4, 5, 6 cannot be the universal set for the sets A, B and C. The first is here, second is phi. A is not subset of phi, B is not subset of phi, C is not subset of phi. Therefore, phi cannot be the universal set for the set A, B and C. Third, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The solution. A is a subset of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. B is a subset of, okay, and C is also subset of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And thus, the given set, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, is the universal set for the sets A, B and C. Next, 1, 2, 3, 4, 5, 6, 7, 8. Solution. A is a subset of 1, 2, 3, 4, 5, 6, 7, 8. B is also subset. However, that is a C is a not subset of 1, 2, 3, 4, 5, 6, 7, 8. Therefore, the set 1, 2, 3, 4, 5, 6, 7, 8 cannot be the universal set for the sets A, B and C. And in this way, we have completed the exercise 1.3. Now we'll see in the next video. Till then, goodbye.